then I started watching it.
Alright, you guys, we're going to get started. So, the last couple days of class, we've been going over two-step equations and how to solve them. So, this should be no surprise to you that today we are going to be doing that once again. So, today we're going to learn by a card sort. So, I've passed out bags. You can go ahead and open them and start to look at the cards that I have given you. Start thinking about different ways that you might want to sort the cards.
Push that out of the way. So we don't try to keep it out of the card's way, but so I think that the students are probably going to, for the first sort, put the words in one pile and the equations in and then
whatever the x is going to equal.
Right. Yes. So the solution, and then the equations, and then I would imagine. Thank you. Here we go. So now, is that one? That one goes there. Okay, are there equal numbers?
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This one
interesting. No. Alright, so some of them must have the same solution. Is that what you're thinking?
Yeah. Alright. This one looks like it's going to be x equals
5. So we could kind of line that up, right? And then there might be another equation that fits in there too, right?
Yeah, not
there. It is. Okay.
No, not
all right. Well, no, I was just. Oh wait, where's the? Oh, I see. I see what I did. Okay. I see.
You just live one on the
Yeah. All right. So then this one is going to be negative 4. Negative 2. Is it that? Is it negative 7x equals
24 minus 10 is 14,
but it's negative
7x equals 14, so x is
isn't it
negative 2.
Wait, hold on now. If I move the 10 over here,
Get rid of
then it's positive. Yeah, you're right. Negative 2, and I don't see a negative 2. Did I get all the cards out? I did.
Aaliyah had $24 to spend on 7 pencils. After buying them, she had $10. How much did each pencil cost?
Okay, so that one goes with that. So maybe they don't all go word.
Maybe not.
Maybe not.
Maybe.
Okay, so I'm going to try to pull up this rubric so I can start going into that.
Yeah, you're good.
Here it is. Okay, there it is. All right, so where are we? 6. Let's look at some other. Let's look at some easy ones.
Imani spent 2/3 of her weekly allowance. Here's a 2/3.
Okay, those go together, I believe.
And then earn more money. Her parents let her watch her before, and then it ended with 12.
Definitely, those go together for sure. All right, and then hey, look. Is that? I thought we already worked on that one.
This one right here is going to be the x is 2.
You're right.
So maybe. Maybe. Do we have anyone spending 25? We've got 25 over here, but we don't. John spent 25 at the Braves game. The ticket to the game cost $10. He bought 5 candy bars while at the game. Oh, right there.
Okay, yep.
Right there.
So maybe we want to put that beside that, huh? All right. And then this one, a fifth of, looks like it's going to go this one. This one. Which is actually... Until you use half a cup of flour, yeah. So those go together.
Okay.
Alright.
And then this one, you bought 5 magazines.
Okay, well this is looks like up there. Well, no, there's no X.
And 4 erasers. You spent $25. How much did each eraser cost?
Okay.
He bought 4 erasers.
Okay. Okay, good. Alright, so now we need to see where these go. Didn't we have a half?
We had a third.
This doesn't come out.
Okay.
We have 2/3 right here.
Okay. Alright, let's see. Let's multiply this whole thing by 10. So then we'll get 5x minus 2 equals 7. So 5x equals 9. Something's wrong.
So I'm saying it's not going to be like
Something is terribly wrong.
Yeah, something's wrong there, isn't it? Did I do that right? 5x and then times 10 would be 10 fifths, which is 2. 5x minus 2 equals 7.
Did we put him somewhere? I thought we put him somewhere.
I thought it was
Yeah.
it was with that. Maybe we should put them. These are the unsorted ones, right?
Yeah.
Okay.
Now if I do unsorted ones, 3/2 x minus 4.
still pointed at you.
12 Kyle, Laura, Kyle is the presenter.
They said,
Let's see.
it's the most frustrating thing.
9.
Have we solved all of our equations? This one hasn't been solved yet, or is that the one we were just working on?
Some don't have
Can you
It's different. So we've got. So it's 5 or 2x plus 5 equals 7.
Found them.
So 2x equals 2x equals 1. So we do have that one sorted now.
Okay, so you started with
The question, and then we found the formula.
That's much better.
And then for
Alright.
these,
And these go together. Yes. Okay.
technically,
what is this?
So that one didn't
technically
have
it's
a
a word
solution.
problem,
And it
and then
didn't have, let's see, we have 3 parts missing. We have 3 spaces. Like, I feel like they should go together, but they're just not doing it, right? Okay, so let's say multiply this one by 3, and we've got 2x plus 12 equals 36. 36 equals 24.
What about for James? That's the easiest.
Huh. Well, this does make it more cognitively demanding, doesn't it? If we're trying to figure out.
I wonder. That's 6. Let's see, 1.8 is.
Yeah.
That is
But this isn't the right solution.
Minus
6 minus 1.
No, this is no.
It's still what we want.
Yeah. And there's no 12. This one wasn't 12, was it? If I multiply this by 3, then I get 2x.
Maybe this one doesn't do it.
Does it?
Friends company.
See, 3 times 12 is 36. Divided by 2 is 18 minus 4 is
12. Okay, good. So we have another one.
I think he's trying
They
to.
go together.
I think he's
Now we
trying
have
to
this
give me
one
one.
little longer than this.
Well, it worked.
plus the $10 she had after.
so one radian one radian equals.
I'll try to catch you on video.
So I tried to come up with I'm just talking to them about my 3-day lesson.
Oh, okay. Okay, he wasn't really talking about this activity. He was 3-day unit.
No, do it like,
Together?
yeah, do it this
You want
way.
to start putting it back
It'd be easier to spread it out one. Because I did it the other way.
I know. I felt a lot of cognitive dissonance when they did that. Look at what they're doing over there.
I was only like do one wrong, but
But how did you catch
I don't know how to like carry the conversation.
Okay,
Well, let's see what he does.
all right, everybody, let's come back as a group.
Because
So, some things that I want to discuss. How did you originally think to sort these cards? Yes.
Our group started by doing, we put all of the equations in one pile, all of the x values in one pile, and all of the word problems in another pile.
Okay, so you sorted it originally. The equations. Then you said
We did the equations, the x values, and the word problems.
That's the neatest I've ever seen Kyle write.
Big pictures, man. Tighten it up. Shut
word.
that's right.
Yeah, right, John.
Okay, so did anybody else begin sorting them differently than this? Okay,
Go ahead.
Chris or Steph, either one.
I don't know. Go ahead. Ladies first.
Okay, so we just looked at the word problems, and then from the word problem, we looked for the equation that could have represented the word problem. And then
So
from
you first looked at the word problem,
Mhm.
then you tried to match that with an equation.
And then we worked out the equation and found the x value solution.
Okay, so then you found the x value solution. Okay, did anybody else?
Yes, we started more with the equation. So we
Okay.
solved the equations and then looked for the x value and then tried to match up the word problem. We got really frustrated when everything didn't match up perfectly.
Okay. So you
Did anybody
started
else?
with
Oh, no,
equation.
we had that.
With some leftovers.
Leftovers, yeah.
Some residuals.
That's good.
Okay, so notice that this group right here started with a word problem and tried to match it to an equation. But this group right here started with the equation and tried to match it with a word problem. So is there any problem with that?
No,
No? Why not?
everyone does things differently.
Okay. So there might be
might be frustrating.
multiple approaches to this, right? Okay. So something else that I would like for somebody to come up and present is how you might have solved the equation. Everybody look at O for me.
Oh, there's O. Okay, yeah.
What's the equation?
So, who would like to come up and show your work on how you solved that equation? Araceli, you can come up and show.
Do you want? I don't know. For some reason, it's irrelevant for a moment.
so that we can see it.
Okay.
So what we can do first is make these into 4 of the equivalent fractions. Or we just multiply 2 and 2 and this one 5, so we can have the same number in the bottom.
What is that number in the bottom called?
The denominator.
The denominator, correct.
So now since we want the x by itself, so we can stop moving things to the other side of the equation.
Okay, can I stop you right here? Does anybody know what it is called when we, so right here, can somebody rephrase what she did from this step to this step? Yes, Jen.
She's subtracting 5/10 from each side, so that she can try and get her x by itself.
Okay, so she's isolating her x on one side.
Yes.
Okay.
And she
So,
wants that just do that.
okay. So, in other words, she's using an inverse operation. You had it? I'm sorry, Tanner. She's using the inverse operation in order to isolate x on one side of the equation, like she has right here, and then on the other side of the equation, she's using that same inverse operation. Why is she using the same inverse operation on the other side of the equation?
Because it's an
Yes, go ahead. Go ahead.
because it's an equality.
It's an equality. Okay, so what does that mean, inequality?
Inequality is both sides have to be equal, so what you do to one side, you have to do to the other to keep it equal.
Okay, so you're saying that if on this side of the equation, if when we subtracted 5/10, if we would not have subtracted it from this side of the equation, then it would no longer remain equal?
Yeah, it would no longer remain equal to what it was before.
Okay, so go ahead and complete this.
Oh, time out. So she just said equal to what it was before.
Yeah.
Is that really the case? Because the left side isn't equal to what it was before.
You're just changing the equation. And so you're changing the equation from the original equation. You're manipulating things.
Yeah.
You want to take over there?
So you're saying that, go ahead and repeat that again.
You're manipulating the equation, and then both sides will be, it will be a new equation, but it will be balanced on both sides.
Okay, so even though this equation right here that we started with is not the exact same as this equation, it will still, we're saying that this expression on this side, this expression on this side is equal to this expression on this side, right?
Yes.
And now when we go down here, this expression is still equal to this expression. Okay. So go ahead and conclude.
Thanks for saying it that way, because
I just wanted to point out that this is so cool because it's just like the additive property of equality that we talked about last class.
nice job.
Yay! Keep that in mind for John. Teamwork right there. Makes the great work.
Oh, it is really okay.
Okay, let me ask you a question. Why did you multiply by 10 over 2.
Because here we're multiplying it to x, and so if we do the step that comes before this, we can then say it would be 2, let's say dividing by 2/10, and then this would be equal as to down here because I don't want to say they keep change.
No, don't say that.
No.
Thank you.
It has a name.
I know, but I can't remember it right now.
Okay. Somebody want to help Araceli out?
Reciprocal.
Okay, so when we divide by a fraction, then we multiply by the reciprocal.
But why?
Yes, why do we do
We
that?
don't have to go all the way back to that if you don't
We're
want
not going to do
to.
it?
That's okay.
So go ahead. Does everybody understand that when we divide by a fraction, we multiply by the reciprocal? Everybody understand that?
Yes.
Okay, so go ahead and complete this one.
Chair.
Okay, thank you. So is this what everybody got for this one?
Did we? Good.
Yes?
Because sometimes you make
Okay, so I just wanted to point this one out because we had a lot of different things going on here. So how she decided to solve her first step in this equation was that she wanted to get common denominators for all 3 of the fractions that she has. So what she did was she multiplied this one by 2, multiplied this one by 5. Okay?
By 5? By 5?
By 5 over 5. Because that's the same as... What is 5 divided by 5? 1, right? So we're not actually changing the value of the fraction. So then down here, this was our result from right here. And then I think that everybody, we walked through the rest of these steps so that everybody can see. Okay? Okay, there. The stuff that I said it now, there, I guess that's it.
See, it's not just me.
Quick.
You just go back.
And then these were some of the reflections. Do you want me to go over the reflections? We don't really.
So I'd just like to ask a question.
Okay.
Tell us about, because we had some leftover cards that didn't fit.
Oh,
Are we
okay.
wrong, or did you do that on purpose? And if so, why?
I did that on purpose because if you notice, some of the equations that don't match with the word problems have some of the same numbers that are in the word problems. So I didn't want students to just look at the word problem and try to match it to a bunch of numbers in an equation. I wanted them to actually be able to look at the word problem and set up an equation.
Nice.
So we had to read the word problem.
Mm-hmm.
Yeah.
So
Instead
no,
of just looking for numbers in the word
Five,
problem.
2/3. Cool.
But I definitely used the negative first, and then was working in my head. I was like, wait.
I know. I kept thinking there should be a -2 in here, and there's not. Yeah. Okay. Thank you, Kyle.